Hi, hello, welcome you all, everyone. Today we will discuss in mechanical streamline in that automation and robotics pathway. That course code is 20 ME 51I, fifth semester for fifth semester. And today we will discuss week 10 syllabus. In that we'll start discussing session 1. In that course outcome covers is 4. So what is that week 10 syllabus means? Develop a simple welding robot program and simulate using suitable software. Before we're getting into a different software, I try to give the introductions about welding and what are all the types of welding that we can do by using a robot. And here course outcome covers develop, simulate, interface and execute robot program for a specified process in an automation system. Table of content, objective, introduction, manual versus robotic welding, advantages of welding, limitations of robot welding, what are welding robots used for, different types of welders, robot welders, the welding industry is evolving. In that objective, as we know, to give introductions about robotic welding. Before we're going to get into the different simulation software, I am trying to give the introductions about robotic welding. Introductions. Robot welding is the use of mechanized programmable tool called robots which completely automate a welding process by both performing the weld and handling the part. That means we are feeding a program to the robot. That robot will take care about welding and material handling process. Manual welding versus robotic welding. We will just compare how the manual welding and how the robotic welding differ. As the name connotes, robotic welding is welding automation that uses a welding robot arm to weld. In this type of welding, the robot moves the torch along the joint to weld the piece together. Compared to manual welding, robotic welding is faster and has higher productivity. This is because the robot does not need to take breaks. The welding cost per piece also decreases since the welding robot can produce more welded parts than its human counterpart. And we will think that robot means that is now we are adopting or now we are developing so many technology to develop a robot. Okay, so now it is developing like that we will think, but it's not true. Actually, the robot started in 1954. That is George Duval, the American inventor, invented the first programmable robot in 1954. Later on, he created the world's first industrial robot. After that, he established the world's first robot company called Unimations. Here, in this company, Duval and his colleagues created the first industrial robot. They called it Unimate. This Unimate is used by American automobile industry, that is General Motor industry. There, they used this Unimate robot for a spot welding. In 1978, with General Motors money, they provided money or they invested for this Unimation company made the programmable universal machine for assembly called Puma. This machine is still in use today. In the 1980s, the industrial robot industry grew. From industrial robot, smaller collaborative robots called cobots, that means collaborative robot means along with the robot, human also can enter in that cabin and along with that robot, parallelly that robot with help of human, they will do welding. That is cobalts called cobalts. human robot interactions where humans and robots are in close proximity were invented to work alongside humans. Further, advantages of welding robots and limitations of welding robots. Advantages. So, as we know, increased productivity. The robot will not take any break continuously once if you program and if you paste that program in that robot controller, it goes on producing a work or weld before that person or a operator switch off that robot. It goes on producing the welding part. Constant quality. Definitely, once if you program a robot before it is switch off, it goes on producing a work with a quality. So that means as if you compare the human welding, so maybe around in 10 pace, he may actually work or actually done the welding around, or actually he produce a good welding component around 5. But the robot out of 10, it will produce exact welding for 10 also. Out of 10, they will produce 10 qualitative welding product. Reduce waste and consumables. Definitely, we know as programmer feed the exact program according to that program, that robot start giving welding continuously. That means accurately or exactly it will do welding. So that means consumables, maybe filler materials or some other nozzles and all, that will not waste. That means exactly what we fed to robot, that much of work it will do. We can avoid waste and all. That means by human, if he not done, or if definitely that welder need a skill labor, the skill he has to learn that skill, and with that skill only he have to do that welding. If he not have any skill means definitely he waste many filler materials or electrodes. That will not be in the case of robots. Exactly it will do welding. And limitations of welding robots requires programming and training. That means for robot, definitely it required programmer. That means a well known language, that robotic language known programmer. He have to feed a program to that robot. Then according to that program only, that robot will do work. And that programmer also need to get more and more training to understand the robot language, which software we are using. According to that, it will start working. That person called programmer have to take more and more trainings. Needs a considerable investment to start. Yes, definitely. For starting, investment is more in that robot for installations, cost, and then later, maybe 2 or maybe 5 years, he may get back his money. But initially, for investment, it will take a lot of money to invest to get a robots. Next slide. What are welding robots used for? Currently, welding robots account for 20% of total amount of welding in the USA. However, this number is rising fast. Generally speaking, industries use robotic welding where high production rates are required. Spot welding, usually used in the automobile industry, is one of the most popular welding robots. Yet, arc welding is also becoming an increasingly popular choice for the use of welding robots. Here, next slide, we will discuss that what are the different welding robots in the market. The different welding robots types are: first one, resistance spot welding robots, collaborative welding robots, shielded metal arc welding robots, robotic gas metal arc welding, robotic gas tungsten arc welding, robot laser welding, plasma welding. We will discuss one by one what are these types of weldings. Next slide. First, we will discuss resistance spot welding robot. Most probably, this welding is used in automobile industries. The automotive manufacturing industry commonly uses resistance spot welding. We know what is spot welding. That means there will be a two electrode, one is moving electrode and one is fixed electrode. In between that, if you place a plate, okay, that current from this electrode will start flow towards the another electrode. In between that, we are placing a metals, so that metal will resist the flow of current. Then because of that resistance, heat will generate. That heat is enough to melt this parent metal. Then by applying a pressure, by applying a force in between these two electrodes, this area will get welded and the solid bond will produce. It's a resistance welding process that uses larger electric currents to join two or more sheets in a single location. The welding gun has a pair of electrodes that can open and close. That already I told that it have the two electrodes, one is moving and one is fixed. In between that moving and fixed electrodes, we are placing a plates. And once if you switch on that welding gun, spot welding gun, in that in between that electrodes, the plate resists the flow of current. Because of that resistance, that electric resistance, there will be a heat generations. Because of that heat, that parent metal will melt, and by applying a pressure in between these two electrodes, that two parallel plates will get bond each other. Okay, next one is collaborative robot welding. As we know the name collaborative, that means collaboratively, that two between there will be a interface between human as well as the robot, both inside a cabin, in a welding cabin, both human and also the robot parallelly, correspondingly they will do weld. Collaborative robot welding, or cobalt welding for short, is also a robotic arm, usually 6 axis, with a welding torch as its ends effector. Unlike industrial robots, cobalts can produce alongside humans. Because of this, there is no need to house them in a welding robot cell. They are also easy to deploy and redeploy to different tasks. Okay. Next slide is shielded metal arc welding robot. The name indicates that shielded metal. That means we are shielding a welding pole by certain gas. Because why we are shielding a welding pole by certain gas means that welding pole should not contact with the atmosphere. That means if it is contact, then contamination may take place, that oxygen or some other gas may trapped inside a welding pole and that weld become weak. For that, we are making a shield by using some gases. Here in this raised shielded metal arc welding robots, here what we are doing means, here that the electrode what we are using is consumable electrode, and the electrode is coated with a flux. During the welding, that flux will evaporate and that becomes gases and that covers the welding pole. Shielded metal arc welding is also called stick welding. In this type of welding, an arc is created between a consumable flux electrode and the welding material. A shielded metal arc welding robots need to consider a variations of the tool centered point. That means tool center point means the is a variable used in robots for a computer to keep track of the tip of the tool. Here the consumable electrode is the tip of the tool. The consumption rate of the electrode determines the directions of the robot arm. Okay. Next type is robotic gas metal arc welding. Just like the shielded metal arc welding, it's also a MIG welding. That means here they will use consumable electrode. But here in the shielded metal arc welding, that flux coated in that electrode is evaporate and form a gas. But here, for making a shield to that welding pole, separate gas nozzles they provided. That gas may be inert gases, that gases, helium or argon maybe. That gas covered the welding pole and becomes shield that avoid contaminations, atmosphere contaminations to enter inside a weld pole. Robots are used for robotic gas metal arc welding when high deposition rates are needed to get high production rate. In gas metal arc welding, a consumable electrode is melted and acts as a filler material. Robotic gas metal arc welding is used for welding stainless steel, copper, nickel, carbon steel. It's usually used for metals that have high melting point of conductivity. Okay, next one is robotic gas tungsten arc welding. As in the case of robotic gas metal arc welding or shield metal arc welding robots, here we are using a tungsten electrode. It is a non-consumable electrode. It is not consumed when we are welding the two metals. Gas tungsten arc welding robots are used when welding thin parts or wanting aesthetic and precious welds. In robotic gas tungsten arc welding, variables such as torch movement, shielding, gas preflow, pulse frequency, etc., are automatically controlled. Intelligent gas tungsten arc welding robotic welding systems have cameras that helps with joint locations tracking and error detections. The robot then takes a picture before the arc is established and compare this image to the reference image. That is about tungsten gas welding by using a robot. Here we are using a non-consumable electrode during welding. Okay, next slide is robot laser welding. As we discussed the previous welding techniques, they're using electrode. That means in between electrode and the workpiece there will be a small gap. When that current is jumped in between that small gap, that arc is produced. Because of that arc, the temperature goes on increasing. That temperature, that high temperature is enough to melt a parent metal to make a solid bond. But in laser welding, instead of using electrodes, they use laser light. A laser welding robot is a type of welding that uses a focused laser beam as the energy source. As a heat source, they used focused laser beam. Laser welding can either be through heat conduction or deep laser. It's usually used to weld materials of different thickness from different angles and different directions. Medical devices and aerospace industry typically make use of robot laser welding. And the next one is plasma welding robot. So here we will call this one just update of the TIG welding. That means tungsten inert gas welding. That means here also they use non-consumable electrode and they used tungsten electrode, but they for creating arc they will use plasma. See here, this type of robot welder uses a plasma arc as that heat source to melt the junctions of the two metals that needs welding. Plasma welding robots are equipped with a plasma torch. A tungsten electrode is suspended inside the torch. The electrode compresses the arc, so the plasma flows from the torch at high speed. Plasma robots are used for welding a varieties of metals regardless of their thickness. Robotic plasma welding is well known for precious and welds and short cycle times. Okay, these are all the different types of welding that we can do by using robot. And the next last slide is the welding industry is evolving. As we know, for we can compare the welding done by human as well as in robot. Definitely we that production rate and the quality is improving. The welding industry is constantly evolving. With robot welding and cobalt welding in the industry, both small and medium welding business can harness the advantages of robot automation. It's undoubtedly an existing time for the welding industry. At the rate of technology is evolving, who knows what tomorrow's welding technology will bring. So this about the different welding techniques or welding that we can do by using robot, and how this when this robot welding started, and what are the introduction part it have before you're going to know about, or before you're going to use the simulation software for welding, what are the things we should know, the basic things we should know about the robot welding that we discussed today. Okay, thank you one and all, the moderator Dr. Chennakeshwar KR and subject expert Mr. Charan Kumar E for providing me to give this presentation on the robotic welding, and myself Rajesh CM, content developer from GPT Carver. Thank you all.